Hello everyone, and welcome to the Stacks Overview lecture. So what is a stack? A stack is an ordered collection of items where the addition of new items and the removal of existing items always takes place at the same end. So this end, where the addition and removal is taking place, is commonly referred to as the top, and then the end opposite to the top is known as the base of that stack. So you can almost think of a stack as a stack of books on a table. So the base of a stack is significant since items stored in the stack that are closer to the base represent those that have been in the stack the longest. And the most recently added item is the one that is in the position to be removed first. So this is known as a last in, first out principle, this stack ordering, sometimes called LIFO. So it provides an ordering based on the length of time in the collection, where newer items are near the top and older items are near the base. Let's go ahead and see a diagram to show this. So here we have an example of building a stack and then removing items from a stack. So in this first figure here, section 1, we can see that we start with a element 1, and then we push a new element 2 to the top of the stack. Then 3 also goes to the top of the stack, and same with 4, 5, and 6. So we're pushing them to the top of the stack, but basically almost like you had a stack of books on a table and you were piling them on top of each other. Push is just a term that's commonly used for this method or operation, and we'll see that when we implement a stack in the next lecture. Now when you're removing items from a stack, the last in is the first out to go. So for instance, 6 was the last one to go in, so it's going to be the first one to come out. So when you're popping the items off, you're basically taking them off from the very top of that stack. Okay, so note how those first items are being pushed to the stack begin at the base, and as the items are popped out. Stacks are fundamentally important as they can be used to reverse the order of items, and the order of insertion is the reverse of the order of removal. So if we go back, we'll notice that we'd be able to reverse this entire stack by merely popping it out. So right now I have 1, 2, 3, 4, 5, 6 as I push them in. But if I decided to pop these out into a new stack, that would basically reverse the order. I'd have 6, 5, 4, 3, 2, and then 1 finally. So just keep that in mind. Considering this reversal property, you can perhaps think of examples of stacks that occur as you use your own computer. So for example, every web browser has a back button. And as you navigate from web page to web page, those pages are placed on a stack. Actually, it's the URLs that are going onto that stack. So the current page that you're viewing is on the top, and the first page you looked at is at the base. So if you click the back button, you begin to move in reverse order through the pages. Okay, so hopefully Stacks was pretty basic and you understood the concept. Go ahead and go over that figure or even go over the Wikipedia page on Stacks in case you're having any trouble understanding. But it's basically a last in, first out principle. To get a better idea of this, we're going to go ahead and implement our own stack class in the next lecture. Okay, thanks everyone. I'll see you at the next lecture.